Okay, let's start with a brief historical outline of the development of the field. And as you well know from your general reading, that astronomy is man's quest to understand, or man or woman's quest to understand the universe and its constituents. And it goes back to ancient history. And some of the most spectacular things that the ancients witnessed were things which appeared periodically. They obviously studied the stars, they observed emotions, they observed the planets, but there were extraordinary things like comets, for example, which would appear periodically. And these were initially believed to be forebears of doom and disaster among different civilizations in the world. And here what I've shown you are two comets. One is a 14 magnitude comet towards the constellation Ursa Major, which was observed in 2014. And you can see the faint comet over here in the middle of the picture. The right is a much brighter comet, Comet C 2020. It was observed in July 2020. And this was a picture which was taken by NASA's Parker Solar Probe. And what you can see over here are two tails over here. One is called the dust tail, and the other is called the gas tail or the ion tail. And comets are basically consists of ice, dust, there's rock mantle inside. And as it approaches the sun, the gaseous components evaporate. And what you see over here is the dust component being left behind as a comet goes ahead. And then there is also the solar wind that you got to contend with. And the solar wind is responsible for the ion tail, where the solar wind buffets the tail, the gas is ionized. And these periodic comets, actually you can find stories about it in all different cultures. And this is where you are part of this journey, right from ancient times, of trying to understand, as I said, of the constituents of the universe. Clearly, the ancients did not have the kind of tools that we have today, or the kind of physical understanding that modern science has developed, or even the technology to actually go and visit some of these, or have probes which fly by some of these components of our universe. But clearly, there was no lack of interest in trying to understand what these various components might mean. And as I said, you were usually sort of believed to foreshadow or bring in doom and disaster. And although if one did a statistical analysis, you would find that that these were not well-founded even in ancient times, but such were the beliefs when you didn't have a physical understanding of the universe. So as attempts towards understanding a universe goes back to ancient times, and one must stress that these were influenced by their own mysticism and belief systems. Although today we know that astrology has no scientific basis whatsoever, but for a long time, astronomy and astrology were very closely linked together. And ancient civilizations were actually intimately connected to the sky. Today, particularly when we live in the cities, we don't see too many stars. And due to light pollution, the sky is bright. You can only see the brightest stars often. If you go to the villages, you will see more stars where there is less light pollution. I grew up in a small town called Shillong in the northeastern part of the country. And there we could actually see the Milky Way. Such clear nights were there during the winter months. And meteors were often sort of seen quite easily. And this was, but modern sort of in the cities, it is very difficult to try and see the kinds of stars or the number of stars which you would see from darker regions like in small towns or villages in the country today. And ancient civilizations actually relied a lot on the sky. For example, if you think of indigenous Australians, the Aboriginal Australians who lived in Northern Australia in the deserts over there, then their only way actually were to actually know directions was by looking at the stars. And also they kept track of the stars for their own sort of everyday life, because it brought in sort of different constellations you would see at different times of the year. So they were intimately related to the seasons. Today, of course, we sort of have calendars which you look at, we have our mobiles, or we have iPads, which we look at the date and the time, etc. But that was very different when it was in those 1,000, 2,000 years ago. So we have essentially lost touch with the sky. So we don't often know the constellations, and as students, I would sort of encourage you to at least, now it is monsoon time, so the sky is not clear in most places in the country, but in wintertime or when the skies are clear, just look out and try and identify at least some of the basic constellations. And when I say that the ancients had their own mysticism and belief systems, one should also sort of mention that it may not be correct to judge and scrutinize them from today's perspective. It is important that we don't patronize them. It's also important that we don't sort of be overcritical of them or critical of them, because it's just try and understand and appreciate the cultures they lived in and their efforts in trying to understand the universe. From astronomical observations made by ancient civilizations, we developed concepts of time and a calendar. It was the ancients, the Greeks, etc., Indians, Greeks particularly, who developed daily timekeeping, rotation of the earth. They kept track of the seasons, revolution of the earth around the sun. They kept track of lunar cycles, the phases of the moon. And they also noticed that although the planetary systems may not have been clear at that point of time, but they noticed that some stars were wandering stars. They moved much more rapidly, whereas the background of stars were relatively stationary. Today, with modern techniques, we know that even stars which appear stationary to us may have their own motion, what we could refer to as proper motion, and we can measure with telescopes with high angular resolution, and monitor their motion from year to year to year, and we can look at the motions of the stars. But the planets are clearly moving much more rapidly. And the word planets actually came from the Greek word planetus, which means wanderer. So as I mentioned, the distant stars appear fixed, but even then they have motions, which you call proper motion, and they could be just milliarc seconds per year. So, and today we have telescopes which over a period of time can monitor the motions to a very high level of accuracy and understand the proper motions of stars. And we shall see later what we can learn from that. The ancients also developed an understanding of the eclipses. Aryabhatta also made important contributions towards this. And the viewing of comets, which I sort of first drew your attention to, goes back millennia, actually. What I have shown over here is what are known as the Maungui silks, which were found in the Yunnan province in the 70s. And these texts, which are written on silk, contain varied aspects of human life and issues, but this particular one talks about sketches of the comets. And you can see how meticulously actually they have recorded what they have seen. And it's just wonderful that these things have been preserved from about 300 to 1500 years before the Common Era to the modern age, where in such pristine form that we can actually sort of see details of their writings and try and understand what the ancients tried to explore and understand about the universe at large. When I talked about calendar, one can ask oneself, what was the first calendar? When did they make it? And what form did it take? And the earliest lunar calendars seem to be from the cave arts found in France and Germany. These archaeological records trace an awareness of the stars in the heavens to the Aurignacian culture of Europe, which is about 32,000 years before the Common Era. And what were the signs? The signs were actually marking the phases of the moon and the seasons of the year, okay, that can be counted. You can appreciate that they may be out on long hunting trips to get food. They may move from place to place in search of food. They may be nomadic. So they had to also carry this around. So it had to be lightweight. So they were sort of engraved in stones or bones or antlers, such as of deer. And there are various records, as I just mentioned, of these of these phases of the moon, which has been interpreted to be to keep track of the seasons. And this is effectively some of the earliest forms of the calendar. One of the very main workers is Marshak, who has written sort of extensively on this, including a very well read book. The sky was not only a calendar, but also a tool to navigate vast distances. And these two sketches I've taken are from the Aboriginal myths and legends, based on not just the constellations, but also dark spots. In most cultures, you'll find that the star patterns fit into constellations, whether it be Western or Indian. But in the Aboriginal communities, you also find a lot of myths and legends based on dark spots, which you can see over here in our own galaxy, the Milky Way. The sky indicates when seasons are shifting and certain foods become available. They also enable them to navigate vast distances across Australian deserts. And this is the Orion constellation over here, with Betelgeuse and Rigel at the other ends. And over here, it talks about the Yolngu people. They talk about three brothers who are in the boat, and this is where they sort of catch fish. And this particular picture was put together by a friend and collaborator, Ray Norris. And this picture was put together by his son and Ray as well, Barnaby Norris, for which he had received an award as well. And what I would like to point out, which we will see later in the course as well, that while our galaxy consists of billions of stars, or billions of stars, that when you look at the Milky Way at the optical wavelength, you see these very dark spots over here, okay? And we will try to understand what these dark spots are due to. And what they figured out was that this was this sort of legend which goes with the emu in the sky. And when this particular sort of picture appears in the sky, the emu lays its eggs, and it is something, food which becomes available for the Aboriginal people. And there is also a cave recording of this, which is probably goes back thousands of years, probably about 10,000 years or so, in the Kurungai Chase National Park, which is in the northern part of Sydney. So you can see that in the ancient times, myths and legends were built up on what they observed in the universe. But they were very careful observers, and they noticed these dark patches in the sky. They noticed the sky patterns, and they wove their own sort of stories to understand them. So not only the observations of patterns of stars or patterns of dark clouds in the sky that they noticed, they also built enormous structures to try and hopefully understand and observe some aspects of the universe. I will not be exhaustive at all, because this is not a history of science course or history of astronomy course. What I will try to do is just give you one or two examples. Many of you would have heard about Stonehenge, which was built in large stages from about 2100 years before Common Era to about 1500 years. It took about 1500 years to erect. And some stones are missing, some have been taken away over the years. And it consisted of 100 massive upright stones. And these were, some of these were carted from at least a couple of hundred miles, about at least a couple of hundred miles or so away from Wales. Some were from more nearby distances. And these weighed sometimes more than 40 tons. You can read a lot more of them in the web. These are believed to be burial grounds, but the purpose also appears to be astronomical. The view of the sun rising on the summer solstice, you can see it directly over one of the stones called the heel stone. It appears to have kept track of the moon. There are stones which mark the maximum position from which the moon is seen to rise. And there's a sort of small interesting BBC video as well. So although it may have served various purposes, it also seemed to have an astronomical significance. And imagine sort of these structures which are built over hundreds of years, and the same quest for knowledge continued from generation to generation to generation to try and build these structures. I mean, today, if you build a modern telescope, it can take decades But these you can see literally took a millennia or more to actually put together with the technology or tools available at the time. Just another example, the ancient pyramids at Giza, which were built in the third millennium before the Common Era, and the history of it has been pieced together from sketchy records of kings, the pharaohs, the Egyptian dynasties. And what is remarkable is that when you look at these three um, pyramids over here, they're aligned north-south within about 0.05 degrees. And here too, the sandstones were tagged along from, long distances, couple of 100 miles or so. But the amazing question to ask oneself is, how did they actually align it to such a great accuracy? Today, we know about the polar star, the North Star. And the North Star, we can point to the North Star and say it is nearly the North Pole. But what happens is that the Earth precesses. Not only it sort of rotates on its axis, it also revolves around the sun, but it also precesses, just like a top precesses when you spin it. So because of the precession of the Earth, the North Pole was not at the North Pole at the time the pyramids were built. They were known, okay? So how did they actually determine the North? So you could see, for example, the picture I show on the right over here. This is a picture taken by David Malin, one of the very well-known astrophotographers, astronomers from Australia. And you can see that there is no equivalent of the North Star in the southern hemisphere, but you can see all the stars going round. And I mean, you'll obviously not see the stars for 24 hours, but this has been digitally reconstructed, but you can observe throughout the night. And right at the center of the circle would be the South Pole. But did they do that? Or did they adopt some other means? There is a very sort of interesting paper by Kate Spence, which was published in Nature some time ago, which sort of suggested that they followed stars and look at the sort of intersection and then sort of arrived at this very sort of careful alignment with the North. So alignment of Mizar in Ursa Major, the Big Dipper, and Kochab in Ursa Minor. And what Kate Spence said was that because these stars were also precise, and remember that these were built again over a long period of time. So she said that that the alignment which is seen in pyramids which are built at different times seem to support the conjecture that they looked at stars and tried to determine the North. So you can see that how much importance they laid in not only observing the stars but also in trying to incorporate them into the structures, enormous structures which they built. So there was an important sort of connection of ancient civilization to the stars, not perhaps in the way that we try to understand the universe today, but definitely their links to the night sky was something which was very profound and led to the building of these enormous structures, which we still try to figure out and study in some detail to understand more about it. In fact, the alignments have also been used to date the pyramids more accurately, which has been also used in Egyptology to try and understand, give more precise dates to when the various dynasties may have ruled. In India, I would just draw your attention to two articles. One is by Kameshwara Rao, my colleague from Astronomical Society of India, and he made a plea for megalithic monuments of possible astronomical significance. And but there is no firm structures like for example, the pyramids or the Stonehenge monument. And in terms of timekeeping, there's also an image of a calendar stick from the Nicobar Islands. I mentioned about Marshak earlier, and one of his books, The Roots of Civilization, where he drew attention to these calendar sticks from different parts of the world, which were in all likelihood used for timekeeping. And there is one such example from the Nicobar Islands, a photograph of which is available in this article. Have we built, do we have evidence of astronomical observatories in ancient times? Of course, we have Jantar Mantar and from more recent times, but in ancient times, the Harappan civilization, there has been a suggestion by my colleague from TIFA, Mayank Wahia, and his collaborator, Sri Kumar Menon, but it is not very well established and not widely accepted, but perhaps requires more detailed studies. With this sort of background to what the ancients looked at and understood and built, let us now come to a little bit sort of move on to a little bit more recent than that and move on to Greek astronomy. Again, I've just picked up a few examples because my idea is not to do an exhaustive introduction, but just to sort of introduce you to some of the seminal contributions before we come into the modern era. Hipparchus is an example of one of the very well-known Greek astronomers. He saw a new star in about 134 before the Common Era, and he was so his curiosity was aroused by looking at a new star which has appeared, and to see whether more such stars may appear, he needed to know the other stars which are in existence. So he went on to compile a stellar catalog, and he made a catalog of about 850 stars between about 134 BCE to 127 BCE. And he compared these with positions of about 20 stars or so, which were made about 150 years earlier in Alexandria. And he discovered that the star positions had shifted by about 2 degrees systematically. And he made use of these observations and mathematical techniques which were developed over centuries, starting from the Babylonians, and discovered the precession of the Earth's axis. So you can see that the precession, which is so key to in terms of knowing positions of celestial objects, was discovered in relatively ancient times by Hipparchus. And his Babylonian mathematics and astronomy, he made use of these which predate the Greeks. And some of it actually continues to live with us. I've just mentioned about counting, because we normally, when we count to the base 10. In computers, which is binary systems, base 2. But they developed a system which was counting to base 60. And you might wonder why 60, but if you look at it, 60 is a number which is divisible by 1, 2, 3, 4, 5, 6, okay? Goes on 10, 12, 15. So it's a number which could be easily divided by a lot of the other numbers. And we're still stuck with that, 16 seconds make a minute, 60 minutes make an hour. And even when we measure angles, 60 arc seconds make an arc minute, 60 arc minutes make a degree. So our counting system of time and also of degrees, angles, is based on something which came from the ancient times. The historian Matthew Ossendriver from Humboldt University, he studied many of the tablets, and there is a 3,007-year-old Babylonian tablet, which has been interpreted to suggest that they had developed the basics of trigonometry. You can see about 3,700 years ago. So you can see tremendous developments were made, although tools were meager compared to what we have today, but driven by mankind's curiosity to understand and probe the universe. Staying on the theme of Greek astronomy, but moving ahead in time, the universe was beginning to be understood in terms of measurements, mathematics, and what we may call scientific arguments. Observational astronomy or observational science was beginning to take its root. Aristarchus of Samos in the 3rd century BC had proposed a sun-centered solar system, and the measurement of the size of the Earth using geometry was done by Eratosthenes again at about the 3rd century BC. This is something which you may have studied in your class 12 or even in school, and read about this measurement of the diameter or the size of the Earth, when they realized that Eratosthenes realized that when the sun was completely overhead at Syene, that when you moved north to Alexandria, it would cast a shadow. And he measured this angle, and this angle would be 7 upon 360. And once you know the distance between the well at Zion and the distance to where the pole was set up in Alexandria, you can go and determine what the circumference and then the radius and the diameter of the earth. So this is amazingly close to what modern measurements are. So you can see the quest to understand the universe, make measurements, use mathematical tools is something which has been with us from very ancient times. But you'll also realize when you look at the history of science that there are overriding opinions which are often held sway. And for example, this origin of a sun-centered solar system was not something which actually caught on, because Plato and his pupil Aristotle had the greatest influence till about the Renaissance period. And Aristotle was largely axiomatic. It was not something which he did experiments and tried to verify. And they believed more in the geocentric model of the universe, and that is what prevailed till the time of Copernicus, Kepler, etc. Okay? And although we use the word science routinely today, it is more recent. And this word science has its roots in the old Latin word scientia, which is used for knowledge. And it was more of philosophy, or natural philosophy as it was called, till the word science became widespread. And in fact, one of the oldest, longest running scientific journals is the Philosophical Transactions of the Royal Society, which was launched in 1665 by Henry Oldenburg. So science is basically the integration of nature by the human mind, trying to understand its various aspects. Some of it will be hard science, some of it may be like softer. And it revalidates earlier knowledge or generates new knowledge. And you generate new knowledge by both deductive reasoning as well as inductive processes, and sometimes also what is referred to as abductive. What do I mean by deductive processes? That if you say A is equal to B and B is equal to C, then A is equal to C, would be an example of a deductive process. And if one were to extend it reasoning a bit further, one would say that you build up a theoretical framework based on logic, based on the mathematics that you know, and or mathematics that you develop, and make predictions of the real world to try and see whether that holds up. You arrive at a deduction from your theoretical framework, make predictions, and see whether that is true or not. In that category, Einstein's general theory of relativity would be an example where he made various predictions, such as the bending of light, which was shown by Eddington to be consistent with Einstein's prediction, which made Albert Einstein theory and name a household name. And the other example is inductive logic. Inductive is where you make a lot of observations and measurements, and you arrive at some general relationships you induce from the observations. Here, for example, I've written down Hubble-Lemaitre's law, which we will discuss a little later, that where from observations of galaxies, they have been able to establish that the velocity at which a galaxy is moving away from us is proportional to the distance. That would be one example. And abductive is where from the facts which are available that you make what is known, what is probably the most likely solution. For example, when a doctor looking at all the evidence that a patient may present to him or her says the most likely cause of the discomfort or the disease or the symptoms is so-and-so and gives you a treatment. Or for example, a jury who looks at some of the evidence or hears all the evidence, but there could be other pieces of evidence as well, and tries to sort of arrive at what is likely to be the most likely scenario or the likely solution. And that is what is often referred to as abductive. In science, there is a constant interplay between deductive from theoretical work and inductive inferences from experimental or observational work. And I'll try to give you an example of both of these two aspects over here.